You know what? I ate some food, I took a break, and I'm ready for a couple more puzzles, or maybe more than a couple. It's still Umnik, and I am again solving genuinely approachable pencil puzzles. This next one is Yajilin, and in the GAPP series they have this tradition of Supersized Saturday, where the puzzles are a bit bigger. Yajilin is one of the most popular puzzle genres, and it's also the one that introduced me to pencil puzzles, because it was the main theme of one of the puzzles in first round of MIT Mystery Hunt in 2022. And it's a good thing that it was in the first round, because we didn't progress much past the first round. But yeah, I did try my hands on the Yajilin, and it was great. So let's try to look at it. Yajilin is kind of like mix of shading and loop puzzle. Well, it's mostly loop, but there is some shading. So the rules: shade some cells so that no two shaded cells are orthogonally adjacent, and draw a non-intersecting loop through the centers of all the remaining empty cells. Clues cannot be shaded and represent the number of shaded cells in a straight line in the indicated direction. So for this example, shade some cells. For example, for this clue there are two shaded cells in this direction, there is one shaded cells in this arrow direction. There could be shaded cells before, that doesn't count for this clue. And there is a loop that goes through all other unshaded cells. Sometimes the rules don't even mention like shading cells, it's just draw a loop, but the unused cells cannot be adjacent, and the clues give the number of unused cells, but it is kinda normal to shade them and usually mentioned. So the very rich genre. Let's look at the example. There are several deductions that kind of start with, even though they are not obvious from the rules, but since I have solved many of those, like I already know about them, but like I will have to explain like why is that correct. So the deduction I'm talking about is that, for example, if we have a corner, then those two cells cannot be shaded. And actually more general variant is if we have a cell that can be used, that is not gray. The gray cells cannot be used, but they also don't count as shade. So I can shade this one, for example, because even though it is adjacent to a gray cell, it is fine. So if we have a cell with just two neighbors, then we cannot shade either of those neighbors. Why is that? Well, the thing is that, let's say that we shade one of the neighbors, but then we cannot shade adjacent cells, and one of them will be this one with two neighbors. But now we shaded one of them. But we must draw a loop through all the unshaded cells. But the cell now have only one neighbor, so it cannot escape. We cannot draw a loop through this cell. And from this, look, you can apply the same logic for any cell with two neighbors. Those two cells must be unshaded. And so, like, it is kind of like, if you don't care about the time, it is very normal to just start the puzzle by finding all the corners and marking those two cells as not shaded. Also, in this particular puzzle, we have those dead end cells. We cannot draw a loop through them already, so they must be shaded, they must be unused. But that also means that those adjacent cells are not shaded, and actually we must draw the loop through them so we can just draw those parts of the loop right away. Now we can also look at some clues. Those zeros clues are very nice, as always, because like we get the information that none of those are shaded, and since those are corners, there is only one way to draw a loop through them. Now, this kind of pattern appears a lot, and in this situation, when we have like two endpoints of the same path, kind of near a wall, on distance 2 from each other, we can look at this cell. It can be shaded. But what if it is not shaded? Then, okay, it has only 3 neighbors. We must go to 2 of them from this cell. Which 2 can they be? Well, can they be both of those? No, they cannot, because we will close the loop in this case. So if this cell is unshaded, we must draw part of the loop like this. Okay, but what if it is shaded? Well, then this cell is still unshaded. And so in this kind of situation, where we have a cell that can that have 2 neighbors that are endpoints of the same loop, and also a third neighbor and nothing else, that third neighbor must be unshaded, must be used by a cycle. And if we know that this cell is unshaded, then we will have this kind of segment. But for now, we can just say that this cell is unshaded. What about other clues? This one clue looks at 2 consecutive cells, and we know that we cannot shade both of them. Not because of the clue, well, because of the clue too, but because we cannot have 2 shaded cells adjacent. And in such kind of situations, I like to put X between them. It signifies both the fact that I want to shade one of those cells, but also the fact that my loop will not be able to go through this border, because otherwise both those shells are unshaded and I cannot satisfy this one clue. And marking where the loop cannot go is very important. Well, that's like how you solve loop puzzles, right? You understand where the loop cannot go, and therefore like understand where the loop must go. It doesn't give us much right away, but it is just like a symbol I'm using in such situations, and it is generally useful. And actually, when we have a situation like this near the border, we can also deduce that the 4 cells nearby will be unshaded. Like we can see that if this is shaded, then this must be unshaded. This is shaded, but then we cannot draw a loop through this. And the same would be true. Like if we shade this one, this must be unshaded. This is shaded, and again we cannot draw a loop through this one. So those are unshaded. This 2 clue, like even before we put this point, we would be able to see that there are 2 dominoes, and so we must shade 1 cell in both of them. And also, like if we have a line where we must like shade some number of cells, obviously from the rules we understand that we can like the maximum we can get is like every second cell. But for cells near the boundary, if we have like the boundary, let's remove this. For example, here we could not shade 2 cells on distance of 2 because this one must be unshaded, and again we cannot draw a loop through it. So on near the border, the minimum distance is 3. Like we have to leave 2 unshaded cells between. But actually, the same is usually true for lines on distance 1 from border. And the reason for this is the following. Let's say we shade those 2, then this must be unshaded, so we must draw the loop through it. Then we must draw the loop here, and this one is also unshaded, and we must draw the loop through it. And here we have a fork. And like this will happen like always if there are no like gray cells somewhere which will like allow us to not draw a loop somewhere. So for example, if this cell was gray, we would not have to draw this part. So in this case, like those 2 shaded cells, they must be like here and here. But this is kind of like more advanced. Well, not really advanced, but it's not an easy observation. But since we already knew that this must be unshaded, then just from dominoes we will get that this one is shaded. And like when you put one of them, it is easier to see that if you put another one here, you will have a fork. So we can understand that this one must be shaded, then this nearby is unshaded and it's a corner, so we draw it like this. We must go to this cell, so we cannot just turn left here, and after that we will have to return left, so we have to turn right away. And left. The rest of the puzzle is just follows from that. Okay. Yeah, with Yajilin, it's there is a bit of an issue that like I know too much, but that is it's kind of an issue of this genre in general, because like it's very rich, so there is a lot of stuff to know, and also it is very popular, so I just encountered a lot of them. As I said, I'm starting by marking like freebies. The 0 means that there are no shaded cells here, and all corners. And actually, like in this corner, we can see that there is only one way to draw it. Not only corners are the cells with two neighbors. Like this one is also a cell with two neighbors, so they must be unshaded. But also this one just shows shaded cell. We can draw the corners right away. And here again, like this cell has two neighbors, so they are unshaded. And I just start by marking all of them. This 2 is a domino plus 1. Now I cannot go here, so this one is shaded. This 4 looks like a lot. 2, 4, 6, 7. Since we can only shade like every other, so we must shade like this. And when we like shade every other cell, we will put a segment between every pair, and if there is a border or something on one of the ends, then we will draw corners from it. Then we will create new corners here and here and here. That is also like very common situation. Now we have this like very cut off area, cut off from everything from the outside world, and as we did with what was it, Castle Wall. Castle Wall is actually like pretty similar to Yajilin. We can look at the number of entrances to this area. For example, we can take like an area like this. So we have 1, 2, 3 entrances, and so we need a 4th one like this. Also, we could look at this area. We have again like 1, 2, 3, 4 entrances. We need an even number of them, so we cannot pass here. If we did, we would have 5 endpoints in this zone, and we cannot match them. Yeah, so this one was just continuing the loop in the corner, and here I cannot connect like this because it will be just one loop, so I'm continuing in the other direction. I created a new corner here, so this one must be unshaded. Here I cannot connect right away because there will be 2 unused cells. Here I have 1 clue and only 1 cell left in its direction, so it's connected like this. And this 1 clue is already satisfied, so this one must be unshaded, and we draw in the loop through it. Great. This 2 clue has one shaded already and one more cell. Continue this loop and draw this corner. Now this 2 clue has one, and this one is the second. And draw a corner, this 3 clue is the remaining cell, and cannot connect this loop. It goes here, this corner, this 3 clue, 1, 2, 3. Now this 3 clue has 0 shaded as of now, and what is left is 1, 2, and the domino here. I cannot shade this one because we'll have a fork here. Here I must use this cell, but it only has 2 neighbors, so it must go like this. This one is unused. Here again we have a situation with 2 endpoints of the same path, so we also know that this cell is used, and therefore it must go like this. Also, if I connect like this now, then what follows is, again, I will close this loop, so I will not draw this one. It's all about just finding simple deductions, like I didn't do anything smart now. In this area I have 1, 2, 3 entrances. So here is the 4th one. Connect the loop here. This corner only has 2 neighbors, so it must go here and here. This one is shaded. Now don't close the loop here. This corner, this 1 clue has only 1 cell left, is shaded, so I don't want to close here because like this big loop is closed, or it is easier to see that like this small one will be closed now. So instead I will go like this and finish the puzzle. That was Yajilin by Shye. Yagit, Ships and Wolves. I don't think I know this genre. There are a lot of rules. Divide the grid into regions by drawing straight lines across the grid lines. Okay. Region lines go all the way across the grid, only stopping if they touch a black dot. Line segments may connect dots. So we have some black dots, and those lines that separate, they like start somewhere and go straight until they find a dot, and then they go in some other direction. Line segments may turn on dots, but they are not required to, so it's okay to go through the dot. Lines may intersect through the grid, but cannot intersect through a dot or branch from a dot. So every dot must have at most 2 segments coming from it. It is not required to use every dot. In other words, dots are connected by exactly 0 or 2 line segments. Okay, so if you don't use the dot, it is connected to 0 segments. Otherwise, as I said, 2. it cannot be 1 because like that would mean that you just stop the region border at some place that is not a region border anymore. Each region must contain at least one animal, and no region may contain two different types of animals. So we have wolves and sheep, and we must separate them. 4 or more dots may not be connected in a loop. So yeah, for every, you must start at a border, like go till the dot, then another dot, then another dot, and in the end you should like end on some again on the border of the grid. So like go like here, and you can go just straight without using any dots. This has a full rules to the puzzle, but a quick glance will show you that we are not using the loop rule in today's puzzle because there are only 3 dots. Smart. One less thing to worry about. This genre is also sometimes called sheep and wolves, or shwolf for short, or goats and wolves. If you want to find more puzzles like this on Puzzlink, for instance, shwolf or goats and wolves will be what you find it under. Okay, I think I never saw this name, but I have seen the puzzle with similar rules. I think it was like black and white circles instead of goats and wolves. Okay. Who's after? Tyrgannus. Let's look at the example. Okay, we need to separate sheep and wolf, so we must have, it just draws the whole segment. Well, yeah, we must have a segment here, but it must go till the dot. We also must have a segment here. Okay, now from this dot I must go somewhere, but I cannot go here or here because I will have this region without any animals. So the only way I can go is here. From this point, if I go here, again I will have a region without animals, so that's bad. I cannot draw a segment here because this will be an empty region. But I need to separate this sheep and this wolf, so I must draw a line here. Okay. So now I also need to separate this wolf and this sheep, and if I draw a line here, I will have an empty region here, so I cannot do that either, so I must draw a segment here. And just finishing, going up is bad because there is an empty region here, going right is bad because there is an empty region here, so I go here. Okay. Starting by separating wolves and sheep that are too close to each other. I cannot draw a line here because there will be an empty region, but that means that to separate this wolf and this sheep I must draw a line like here. Okay, I cannot draw a line like here either. Again, I have an empty region here, so to separate those two I must draw a line like this. those two again I cannot draw a line like this, so I must have this. Cannot have this, cannot have this. So like, cannot have this. From this dot cannot go left or right because either like this region or this region will be empty, so I have to go down. And so now I cannot separate them like this. Well, it seems that this should be a solution. Okay, but how do I get there logically? Well, it looks like I will just try all the options, right? I can't have a line here, so like as I draw here, those two are connected. And so to separate this wolf and this sheep, I need some vertical line. And all of the options except one are bad because of some empty regions. Okay. This is an empty region, this is a good one, this is an empty region, and this is an even more empty region. So this is a good one, and from here left is bad because of 3 empty regions, so I go right, and this is the solution. Okay, that was kind of weird. Gemini loop by Freddie. I also don't know this genre, I think. Rules. Draw a non-intersecting loop through the centers of all cells. Since that's the first time we see that kind of constraint in a loop puzzle. Well, in Yajilin, it is like through all cells that are not shaded. So still not all cells. Cells containing the same letter must be entered by the loop from the same directions. Cells containing different letters must not. In other words, each letter corresponds to a unique shape. Interesting. Penpa notes, while the table below the grid may be helpful for solving, it does not need to be filled and in fact must be empty for answer check to work. We don't have the table in this picture, but I'm assuming there's a table like which pattern corresponds to each letter. So if the whole grid is too large to fit on your screen, it is fine to ignore the table completely and solve that way. Feel free to subtract a few seconds from your time based on how long it took to erase those segments. Okay, so there is a loop that goes through every cell on the grid. And if we look at letters A, we have this lower left corner, or like loop going left and down. F are straight vertical, and yeah, different letters are different, apparently. And we have 6 options, right? 4 corners and two straight lines. So we have letters from A to F. Makes sense. Okay, let's look at the example. Yeah, we have this nice helper sync and all the 6 options are here, but we were told to not draw here if we want answer checker to work. Okay, we have to draw a loop through all the cells, and in such kind of puzzle, almost always you will start by drawing 8 segments in the corners. And so now we know that A must be like this. And we can find another A and draw it like this again. We must go through this cell, and there is only one way to do that, left. For letter C, we know that we enter from the top but also from the left. So this must be the pattern. We cannot connect this loop. Letter B, corner like this, in all the places. Then this cell is only one option, and this cell is also only one option, and so D is pattern like this. So E and F must be straight, and there is only one way to do that. And now we just finish drawing the loops through all the cells. And now we have to remove all those for checker to work. Okay. That makes sense. Start by drawing 8 segments. In A we went through the left, but also we can see that we have A on top, so we cannot go up, but also we have A in the bottom, so we cannot go down. So A must be straight horizontal, and we can draw it in all the A's. D is on the left border, so it cannot be on the left. F is on the right border, so it cannot be on the right. And to use the cell, we must go straight through it, so F comes from down. Have B on the right. And it cannot go down. So in this cell, one direction is already blocked, and 2 of the 3 remaining are leading to endpoints of the same line, so we must use the third one. And B cannot be straight horizontal because A is straight horizontal, so B must be a corner like this. And now we can draw a corner here. C also cannot be straight horizontal, so it must have a line up top, but it can also cannot go right because that was B, so it will go left. Now to use this cell, we must go straight up, and here just one way to make the loop. Okay, D cannot go left, but all of 3 remaining options we have already used this one in B. So D must go down in all the places. use this cell, we must go through, and now down, because otherwise we will close this loop. Here again we have situation when there are two endpoints of the same path and the third option, and since we have to draw the loop through all the cells, we must use this segment. And we also must use this segment, because otherwise it will be like this, and then we will close the loop. E cannot go up, but it also cannot go straight horizontally, so it must go down. And G now goes straight up. We didn't even notice that I found that information. And then F must go left. Everywhere we have F, and C must be like that. Okay, we have drawn all the letters, now just finishing the loop. And now I need to remove. Yay! Alright, and let's do one more. Norikabe. Sounds like almost like Norikabe. Oh yeah, and we've seen Nori, we've seen Norikabe. Now it's time for Norikabe, an idea by our own Freddie hand which combines elements of both. Shade some dominoes of cells, dividing the grid into regions. Shaded dominoes may not touch orthogonally, clues cannot be shaded, and every orthogonally connected area of unshaded cells contains exactly one clue, the value of which represents the size of the area. And dominoes can be, okay. So dominoes cannot touch. Numbers cannot be shaded and represent the size of their connected component. And also every connected area of unshaded cells contains exactly one clue, so there cannot be unshaded component without a number. And there also cannot be unshaded component with more than one number. Exactly one clue. Let's look at the example. So yeah, the genres they mention here, Nori is about shading dominoes, and Norikabe is about this kind of clues which gives the sizes of unshaded cells. But both have like additional rules, so it's not exactly like a mesh of those two genres. It's more like we took one rule from both of them. Okay, so numbers are unshaded. Let's make it so. This component must have size 1, so all the neighbors must be shaded. And all those shaded cells must be part of dominoes. So we cannot shade those cells because otherwise it would be like connected component of size 3. And now we can make dominoes and then make sure that they remain dominoes. Okay. This green connected component, like we cannot close it because it doesn't have a number right now, so we must connect it here. But now it has size exactly 5 as the clue says, so we can't add any more cells there. This is a domino already, so unshade its neighbors. Now make this one domino and again unshade its neighbors. This 5 must become bigger, but it cannot go right because this already has 9. So we have connected component with 2 different numbers, which is not allowed. So it will go left instead. Now it has 5. So those must be shaded. This must be shaded to make this a domino. Then this is unshaded to make it stay a domino. Then we cannot close it. And now this 9, well, right now it's a component of size 5. We have one more connected component of size 3 and 3 more unshaded cells. Those 2 must connect because otherwise we will have a connected component without numbers. Or alternatively, you can understand that if they not connect, then we can only add those 3 cells to this 5 and it will be at most 8, which is not 9. So they must connect, but together they have 8, so we can only add 1 more cell and it must be this one, and so those must be shaded. Okay, great. Now for the main puzzle. Again, all the numbers are green. When we have numbers like this diagonally, we cannot unshade those 2 cells because they will connect. Like we will have component with 2 numbers, which is not allowed. So those must be shaded and this must be a domino. Also, when we want to shade dominoes and we have a pattern like this, we have 1 shaded cell with 2 unshaded on like 2 neighboring sides, then the second shaded will be like either here or here, but in any case we will then surround it by unshaded cell, and this one will also will always be unshaded. And we can do similar things here. Okay, this 2 is already 2, so surrounded by shaded. This is a domino. Those 2 must go further. This 4 must go further, and now it is a 4, so this is shaded. This is also shaded. This is unshaded. This is 5. Those are dominoes. Okay, now this component must go further because it doesn't have a number yet. Now it has a 4 and it's size 4, so we must surround it by shaded cells, and this one is unshaded because it's a domino. We need to continue this domino and then stop it. We cannot make this cell green because it will be 5 already for a component of size 4 supposedly, so this one is shaded and this one is not, like I did here. This must continue here, and now it is 4, so it is surrounded by shaded. Continue this one. This 5 must go outside somewhere. It will have to connect to this group of green cells because otherwise, like, it must take all of those white, but then it connects here. Together they already have 4 cells, so they must take the 5th one here. Complete the dominoes. This one is already 5, surrounded with blacks. This is a domino. Now this is green. This green must escape, and since it didn't say that I solved the puzzle, I'm assuming this is 18. Let's count. 4, 8, 12, 14, 15, 16, 17, 18. So this must be shaded. Great. It was Norikabe by Eric Fox. Interesting variant, but I don't know. Well, I'm assuming that this puzzle was just made easy. I don't think I have seen a genre in which it is impossible to make a hard puzzle. Just like the genre just doesn't allow for deep thinking. I don't think that happens. Or at least like those genres do not become a thing. Like somebody can come up with a rule set and then try something and like, oh, nothing interesting comes from it, and so the genre never take off. Like this one, like it looked very simple. I just always did the necessary steps, but I'm assuming that it is possible to make hard puzzles in this genre. Thanks for watching. Try to solve those puzzles on your own and some other puzzles. And have a nice day.